Before we bounce into the statement, it is vital to figure out what particle gas pedals are. The Immense Hadron Collider, LHC, work by CERN, is a 17M ring of superconducting magnets. Likewise, it is the world's greatest and most remarkable ion smasher. It represents the pinnacle of human intelligent achievement. As a matter of reality, it's so strong that it could recreate the actual conditions of the first experience with the world. Yet, could this machine, designed to open the secrets of the universe, hold the key to something unquestionably more foreboding? CERN, laid out in 1954, is one of the world's most eminent research organizations, with 23 part states and countless specialists. It's a center for cooperation and advancement. The LHC is CERN's chief project, yet it's just a single part of a colossal organization of gas pedals and tests. Imagine a course, not so much for vehicles or ponies, but for subatomic particles in a trial of expertise, perseverance, and space itself. The LHC speeds up protons to practically the speed of light, sending them on a collision course that mirrors the energy of the universe at the time of the Big Bang. The effects create temperatures millions of times hotter than the center of the sun. Countless magnets guide the protons on their excursion, while complex cooling systems keep the magnets at temperatures colder than space. The beams inside the LHC are made to crash at 4 regions around the gas pedal ring, corresponding to the positions of 4 atom finders: Atlas, CMS, ALICE, and LHCb. Each fills a special purpose, exploring remarkable pieces of particle physics. Together, they act as giant cameras, capturing portrayals of these crashes. Researchers then sift through the debris, looking for signs of the interesting Higgs boson, otherwise known as the God particle, and other peculiarities that offer bits of the universe's key building blocks. By focusing on the microcosm, we gain insights into the universe. Yet, with each answer comes another question, and with every revelation, another test. The LHC isn't simply a scientific instrument. It's a demonstration of human curiosity and advancement. It exemplifies our tenacious mission for knowledge and our yearning to grasp the key forces that shape our universe. However, as we push the limits of what we learn, we must also consider the more ethical and existential questions that arise. What are the risks of inspecting the unknown? Could our quest for understanding inadvertently open forces we have no control over? In the hallowed halls of CERN, where the limits of human cognition are continually pushed, a revelation has emerged that sends a chill down the spine of even the most seasoned scientists. Brian Cox, a former researcher at CERN and a voice of expertise in the domain of particle physics, has recently made a statement that has left the world both captivated and uneasy. Cox's words resonate with chilling clarity. The target of CERN's Large Hadron Collider is to replicate a small-scale Big Bang. Yes, you heard that right, a scaled-down version of the very event that created our universe. The physicist also happened to explain the implications of this goal, highlighting the LHC's exceptional potential for making new discoveries. This includes its capacity to unlock the secrets of the Higgs boson and explore dark matter, a mysterious substance that makes up a significant portion of the universe. Imagine holding the power of creation in your hands, the ability to summon the very essence of the universe. It's an alluring prospect, but one loaded with risk. The miniature Big Bang isn't just a hypothetical concept, it's a tangible reality within the LHC. The temperatures, the pressures, the raw energy, all replicate the conditions of the universe's origin. It's like standing at the dawn of written history, witnessing the birth of existence itself. But with such power comes responsibility. And the question looms, what if something goes wrong? In fact, something did go terribly wrong back in 1978. Russian physicist Anat Borsky experienced a calamity that would forever alter the course of his life. While working on the U-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia, a misfire caused his head to accidentally come into the direct path of a proton beam. The beam, with a force that challenges perception, passed through his skull, entering the back of his head and exiting through his nose. Borsky's experience was extraordinary. He saw a flash brighter than 1,000 suns, yet he had no concerns. The beam's path left a trail of destruction, burning tissue and bone, yet he remained conscious and even walked to the center for treatment. The outcome was both disturbing and fascinating. The beam's path caused limited issues, including the loss of hearing in one ear and partial facial paralysis. Yet, incredibly, Borsky's intellectual capacities remained intact, and he continued his scientific career. This episode isn't just an individual misfortune, but a reminder that highlights the massive power and potential risk of particle accelerators. The dangers of a particle smasher like the LHC are not to be underestimated. The potential for unforeseen reactions, the very fabric of reality being altered. These are not the stuff of science fiction, but real concerns voiced by some respected researchers. One of the most unsettling, yet captivating, concerns related to the LHC's experiments is the possibility of creating a small black hole. Black holes are regions of space-time where gravity is so strong that not even light can escape. They are colossal vacuum cleaners, devouring stars, strange entities that lurk in the shadows of our universe. The fact that the LHC could create such a phenomenon, even on a minute scale, is staggering to both the public and scientists alike. Could this black hole eventually grow uncontrollably, swallowing the Earth from within? Scientists at CERN have assured the public that any black hole created would be unstable and disappear very quickly, but the remote possibility has sparked discussions, fears, and a sense of wonder at the power we wield. It's essential to understand how the LHC could create a black hole. It has to do with the basic mechanics of particle accelerators. When protons are smashed together at nearly the speed of light, the energy created is so enormous that it distorts the fabric of space-time itself. Imagine a trampoline stretched tight, and then a heavy object is dropped onto it. The fabric bends, and if the weight is heavy enough, it could create a depression so deep that anything nearby would be drawn into it. This is a simplified analogy for what could happen at the LHC in the realm of quantum physics, where the rules of the universe are both strange and wondrous. There exists a theory that extra dimensions may be hidden within our reality. If these dimensions exist, the LHC's experiments could tap into them, creating a gravitational well that forms a tiny black hole. This mysterious dance of particles has even caught the attention of some renowned scientists, especially the late Stephen Hawking. In his book, he warned of a scenario where the Higgs boson could become unstable at extremely high energy levels. This instability could lead to a disastrous occasion that wouldn't simply obliterate the Earth, however, might actually decimate the whole universe. The regarded English cosmologist and astrophysicist Sir Martin Rees also communicated worries about the trials led at CERN. In his book On What's to Come, Possibilities for Mankind, he investigated the potential risks of atom smasher tests, including those at CERN. His words were not simply preventative. They were pervaded with a sense of existential fear. He discussed a worst-case scenario where a bound test could create a condition called vacuum instability. This instability could, in theory, trigger a phase transition that would echo through the actual fabric of space-time, resulting in an unimaginable calamity that could overwhelm the whole universe. Rees' interests were not limited to hypothetical insights. He relegated a low likelihood to these disastrous results. However, he contended that even a small possibility warrants serious thought. The stakes are incredibly high, and the margin for error is razor-thin. The scientists at CERN have run simulations, examined the theories, and done everything they can to ensure the safety of the LHC. In fact, Brian Cox himself recognized the importance of this, acknowledging the widespread misgivings and concerns surrounding the activities at the LHC. He underlined that there are careful safety measures in place, with comprehensive reviews and protocols to ensure that the LHC's operations are conducted with the utmost attention to detail. Cox reassured that the energies involved are well within what the Earth normally experiences, and the chances of creating a stable black hole are cosmically low. Even if one were created, scientists say it would be so tiny and unstable that it would dissipate very quickly in a burst of energy, a phenomenon predicted by Stephen Hawking known as Hawking radiation. It would be a brief moment of immense wonder, just a quick glimpse into the abyss and then gone. Some have gone further, hypothesizing that the LHC's experiments could open a door to another universe or dimension. While this idea is largely dismissed by mainstream scientists, it has captured the imagination of many and become a subject of interest, fear, and even legend. What lies beyond our universe? Could we inadvertently unleash forces or substances that we don't understand? The idea of opening a doorway to hell has even been sensationalized in various media, fanning the flames of uncertainty. But how did this idea come to be, and what does it mean for scientific inquiry? The concept of parallel dimensions isn't new in physics. String theory, a leading contender for a unified theory of everything, proposes that there may be more than the typical 3 dimensions of space and 1 of time. These additional dimensions could be compactified or hidden from our perception, but they could, in theory, be accessed or revealed under extreme conditions. Now, imagine the LHC as a massive key, opening doors that have been sealed since the dawn of recorded history. When protons crash at energies never before achieved on Earth, they could, in principle, create waves or ripples that probe these hidden dimensions. If these dimensions exist, the LHC could potentially uncover them. However, before we dive too deep into wild speculation, it's important to understand that while the LHC is indeed powerful, there is no conclusive evidence to suggest it will open a door to another universe, let alone hell itself. The allure of the unknown, combined with the mysterious nature of quantum physics, means such ideas will continue to captivate the public imagination. So, should we be worried about the LHC and its potential dangers? It's easy to be swept away by sensational headlines and fears of cosmic catastrophe, but the truth is, the researchers at CERN are well aware of the risks involved. They have taken precautionary measures to ensure their experiments are safe, and they continue to monitor and assess their work with the highest level of diligence. The potential benefits of the research, advances in our understanding of the universe, the discovery of new particles, the investigation of dark matter, are truly remarkable. It's not just a display of human ingenuity, it's a window into the very heart of the universe. However, like any great leap forward in science, it comes with its share of risks, and we must approach it with a balance of wonder, respect, and caution. The Large Hadron Collider represents the cutting edge of scientific research, where theoretical physics meets experimental reality. Its true potential to answer fundamental questions about the universe, such as the origins of mass and the nature of dark matter, is unparalleled. Nevertheless, despite rigorous safety measures and detailed calculations, the LHC still evokes a sense of mystery and fear among some. The sheer scale of the machine and the energy it produces are awe-inspiring, and each new discovery opens the door to strange scientific realms. While most scientists remain confident in the safety of LHC experiments, there are obvious uncertainties. What if new, unexpected phenomena emerge that challenge our understanding of physics and the laws of the universe? The LHC pushes the limits of human knowledge and tests the boundaries of our control over the natural world. As particle collisions recreate conditions not seen since the Big Bang, the profound nature of these experiments raises existential questions about the potential consequences of altering the very fabric of the universe. Nevertheless, the LHC's achievements in particle physics have been remarkable. It has led to the discovery of the Higgs boson, advanced our understanding of the Standard Model, and opened pathways to potential breakthroughs that could one day shape our technological future. Despite the risks, the pursuit of knowledge remains one of humankind's most ambitious endeavors. The journey of scientific discovery is rarely without risk, and the LHC is no exception. Its experiments venture into realms of physics where intuition no longer applies. For decades, physicists have tried to understand the fundamental forces of nature: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force, each playing a vital role in the structure of matter. The LHC has been instrumental in providing clues, bringing us closer to a unified theory of everything, where all of these forces might be unified under a single framework. As humankind continues to explore these frontiers, the very nature of these experiments has raised significant ethical questions. Could advances in particle physics lead to unforeseen side effects for our planet, or even for the fabric of reality itself? These are difficult questions to answer, and they require careful consideration of the broader implications of scientific progress. For instance, the creation of exotic particles or the exploration of high-energy conditions could reveal hidden aspects of the universe, but they also carry the risk of triggering new phenomena that are hard to predict.